Hey everyone, I'm Ms. Milkowski, the mathematician, and today we're going to talk about radicals and simplifying them. Specifically, how do we simplify the square root of 72? So I'm going to show you two different ways. There's technically maybe a third way because like one of the ways has kind of two ways you can approach it for how you can do this, okay? So way one is my favorite way, which is that whatever this number is, you write it as a product of its prime factors, okay? So here we go. Way one. Okay, we're going to write 72 as a product of its prime factors. So we think about 72, okay? We want to write it as a product of its prime factors. I personally like to double things and halve things. So I know 72 divided by 2 is 36. 36 divided by 2 is 18. 18 divided by 2 is 9. And then I can't divide by 2 anymore, so I'm left with 3 and 3. So I made this beautiful factor tree, okay? So I know 72 is also 2 times 2 times 2 times 3 times 3. So I'm just going to write that, okay? 2 times 2 times 2 times 3 times 3. Did I say a third 3? If I didn't before, it's 2 times 2 times 2 times 3 times 3. Yep. Okay, so now because we're taking the square root, that means we're looking for pairs, okay? So for every pair that I have, I cross it out and bring one outside. So I have a pair of 2's, I can bring one outside. This 2 can't get paired with anyone, so it's going to stay there. And then I have a pair of 3's. So I cross it out and bring one outside. Okay, so now I'm looking at 3 times 2, which is 6. And what is left inside? Just a 2. And if we want to make it even more obvious, I can use a different color. Just a 2 is left inside, so it's going to be 6 root 2. Okay? So there you go. That's how we simplify the square root of 72. It's just 6 root 2. Let's talk about another way, way 2. Okay, so for way 2, we're going to say, are there any factors of 72 that are perfect squares? Okay, so we're going to come over here and we're going to say, all right, what are some perfect squares? So we've got 4, that's 2 squared, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and 7 squared is 49. But here's an important thing right here. If we double 49, we get 98, which is greater than 72. So we know that it's not going to be a factor of 72, okay? So what we're going to do is we're going to look at all of these perfect squares and say, can I write 72 as a product of factors, of its factors, and where some of them are perfect squares, okay? So let's think about this. Well, how could I write 72? Okay, I could write it as, does 4 go into 72? It does. Okay, I could write it as 4 times 18. That's pretty cool. All right, are there any other perfect squares in 18? Because 4 is a perfect square, that's great. And you're going to say right away, yeah, there is. Okay, there is a perfect square in there, and that's 9. Okay, so we know that 72 equals 4 times 9 times 2. Well, we don't want 72, we want the square root of 72. So what we're going to do is we're going to take the square root of both sides. Okay, now we know that the square root of 72 equals. Now you're going to remember your properties here, okay, which is that if it's all multiplication underneath, we can split it up, okay, into individual radicals. Okay, so we've got the square root of 4 times the square root of 9 times the square root of 2. All right, so then the square root of 72 equals, well, the square root of 4 is 2, the square root of 9 is 3, and the square root of 2, can't really do anything about that. So now we're almost done. Look at this, the square root of 72 equals 6. 2 times 3 is 6, and then square root of 2 just has to stand. So we're done. And again, if you don't want to write this whole big thing, you can just write, 6 root 2 is my answer, okay, over here. But the square root of 72 equals 6 root 2. Awesome. So you know what's interesting? Because we saw these two here, we're wondering if maybe we could have done this in fewer steps. So instead of writing 72 as 4 times 9 times 2, is there a way to write it as a different square times another factor? And the answer is yes. So this is just, I'm still going to call this way 2, okay? And so sometimes, again, I don't want to give you like a prescriptive way to do this because in math, honestly, there's so many different ways to do all the problems. So I just think it's good to just, I'm giving you another way to look at it. And if that's the way you're going to look at it when you have to do it, great. And if you're going to look at it, a different way, that's great too, as long as it works. Start from this side. with the bigger ones, okay? 36, does 36 go into 72? It does. 36 is a factor of 72, okay? 36 times 2 will give you 72. Perfect. So now again, we didn't want, I'm just gonna rewrite it here. We didn't want 72, we want the square root of 72. So we're gonna take the square root of both sides. So the square root of 72 equals, and then remember we can split this up, okay? So that's the square root of 36 times the square root of 2. And then 72 equals, the square root of 36 is 6, and the square root of 2, we just have to leave. Can't simplify that. So we're done. It just equals 6 root 2. And you can box this too if you want, okay? So again, both ways are right. I don't want to sit here and tell you like, you have to do it this way or you have to do it that way, okay? I guess all 3 ways, if we're gonna call this way 3, they're all right. So you just decide, you know what, this works best for me. This is what I want. I have, you know, anecdotal evidence that a lot of students like way 1, that first way where we write it as a product of its prime factors. But if you're like, no, I like this, then you do it this way. I just want you to be able to understand it. And the way that you approach it doesn't matter to me as long as it's mathematically sound. So there you go. Hey everyone, I'm Ms. Milkowski, the mathematician, and I hope you found that last video helpful. If you have any questions or if there are any topics you'd like to see me cover in future videos, definitely let me know in the comments below. Thank you again for watching. I hope you have a wonderful day, and I'm going to leave you with the most important piece of advice I can give you, which is when you're doing mathematics, always ask why.